For RCR TV, I'm Sean Kinney, and welcome to HetNet Happenings, where we take a look at all things DAS, Wi-Fi, small cell, and much more.
CommScope, thinking beyond today's technology to help you make the best decision for your network and your business. Register today for the Wireless Infrastructure Show, the premier national event for mobile network solutions, produced for the industry, by the industry. Telecom Careers, the #1 global telecom and wireless job board, telecomcareers.com.
Welcome back to HetNet Happenings. I'm joined in our Austin, Texas production studio today by our CEO and editorial director. That's my boss, Jeff Mucci. And first off, Jeff, I want to take a moment to check out this new set that we have. These are old issues of the RCR Trade magazine, right?
Yeah, when we bought RCR 5.5 years ago, we got 30 years of print editions, actually 25 years of editions going back to 1983. So we had our set designer go in and basically cut and paste out a lot of copy pages. We kept the originals intact, so they're all bound in folders, but we've got literally 25 years of RCR wireless history in bound editions, and we've kind of decorated a set for your HetNet show.
All right, well, let's break this thing in by talking about Mobile World Congress. We had a big team over in Barcelona this year. It was my very first Mobile World Congress, and before I went, you kept telling me that this is the Super Bowl for telecom, and it was kind of hard for me to get a sense of what the show was going to be like, but having been, wow, it was really impressive. And you've been 5 or 6 times, right?
Yeah, this was my 6th year since getting involved with RCR Wireless, and GSMA said there were upwards of 90,000 people there. There were 8 halls plus an extra hall, 8-1, and you know, it felt like a mile going from the entrance to the back halls. We spent a lot of our time in halls 2, 3, 4, 5, and 6. We had 6 people there. I think we produced north of 80 articles and over 175 videos from the show. So I think we had one of the largest editorial teams at the show.
Oh, for sure. And those videos, they're going up on our RCR Wireless News YouTube channel at a steady pace. So I'd encourage the folks to check that out. All kinds of interesting news that came out of Barcelona this year. And some of those videos that I shot, we got to spend some time with some of the big name telecom infrastructure companies. And we talked a lot about, you know, on the show we focus a lot on the distributed antenna systems. What I saw a lot of this year was small cell deployments. And, you know, the big ones were Nokia, and we saw some stuff from Alcatel-Lucent and all of those big players over there. And another one we spend a lot of time with, in fact, they sponsor the show, is CommScope. So we had an opportunity to look at some of their connectivity solutions. If we could roll that video, please.
Hi, Morgan Kirk of CommScope. I'm the Senior Vice President of Wireless, and we're very excited to be here in Barcelona at Mobile World Congress 2015. We have a lot of innovation to show off this year, a lot of ways that we're helping the wireless operators make better networks. We service 2 different domains, but both in an EBTR way. That's everything but the radio. We work in the indoor domain and the outdoor domain. In the indoor, we're showcasing our ION-U and ION-E product lines. The ION-U, a product line which we launched last year for North America, has been moved to European frequency bands and is now available throughout Europe to cover train tunnels and airports and stadiums and such. Our ION-E product line, targeted toward office buildings and much of the enterprise space, has added some new innovations available for all of the frequency bands, but adds some new innovations in attachment directly to the core network via a CPRI link. On our outdoor domain, we're working in a lot of different spaces. We've innovated in our antenna lines, making new, more and more greater and greater multi-band antenna lines with better and better antenna performance to improve the coverage and capacity of those outdoor cell sites.
Look at CommScope's product line, and you know, these are the guys that did the in-building for AT&T Stadium, which we've showcased on a previous show. But basically, a big trend that we saw in these small cells particularly is disguising these things in the streetscape. So they're there, but you don't know they're there.
Yeah, street furniture disguised as radio networks is just part of the story. I think the bigger story that was discussed at Mobile World Congress this year was how to integrate heterogeneous networks or hetnet networks into the overall cellular architecture. And it's particularly compounded when you're looking at virtualizing network elements at the same time. Right. So when I take a step back and say what were some of the key takeaways, I think about how are carriers going to reduce their material and labor costs when they're deploying both small cell networks and trying to virtualize network elements at the same time. The trend towards end-to-end optical, right, going from the head end or central office all the way to remote radio head. What does that look like in a small cell or a in-building DAS system? The other big theme with virtualization is, do you have centralized equipment or decentralized equipment? And we're going to talk about some of those divergent point of views. Some specific examples I took away from the show. I met with TE Connectivity, who, as you know, CommScope has announced acquiring TE Connectivity Telecom and Wireless Enterprise Division for $3 billion.
Big deal.
TE Connectivity announced last year an integration with Alcatel-Lucent for a kind of an all-optical solution where they've got the baseband unit from Alcatel-Lucent actually embedded into their equipment. And what that means is, and the equipment is NEBS compliant. And what NEBS compliant means is you could put the equipment in a Bell central office. So if you can envision, instead of head end at AT&T Stadium, for example, that head end actually being in a Bell central office with the baseband integrated with the DAS system, and then taking fiber up to 20 kilometers or 30 kilometers away into a small cell. And with the TE Connectivity FlexWave solution, they can actually push 20 watts of power to 4 different bands. So you could have 4 different bands for one carrier, or you could have 4 different carriers all on one remote radio head. So think about that. You got a Bell central office, so that the wireline business is going down. They can start putting more DAS-like equipment in a Bell central office, leverage their fiber network, connect all the way to these small cells, and have a small form factor in a remote radio head that has 4 different carrier channels on it. And so to me, that's a very efficient way to deploy cellular service or densify your network at the street level, okay?
Yeah, and when we talk about these streetscapes, until I actually saw one and had someone explain to me what I was looking at, it was kind of a tough thing to visualize what I was talking about. I saw you got to spend some time with the Nokia HetNet services people, and they had a really demonstrable setup there. So if we could take a look at that Nokia video, please.
Services for HetNets is our proposition to help operators solve urban congestion. As you can see, they face this increasing traffic such that by 2020 there'll be 1,000 times more traffic in their networks. We think that the solution is to deploy more small cells, to make better use of spectrum and to increase that spectrum. Here's a couple of examples of some of the solutions that we can put in place. In this example, it's a lovely new office building. It's using environmentally friendly materials, but the glass is coated, and because of this, the reception inside the building is very poor. In this case, it can be small cells that's the best solution, so we can deploy our FlexiZone Indoor Pico small cell. Another example is coming in a second then. In this example, it's perhaps a shopping centre or maybe an urban business district, and in this case the macro's not able to cope. Rather than deploying small cells, we actually find the most efficient solution in this case is to upgrade the macro and to go from 3 sectors to 6 sectors, and this is going to effectively double the capacity. So we can help operators to find the best technical solutions, but cost is also important. Operators nowadays are facing challenges in terms of their revenues, in terms of their profitability. So they want us to find the best solutions. We can model the total cost of ownership to decide which solution is going to be the best. In this particular example, it's a project from the US. It was to do with small cell planning. We were able to plan fewer small cells. This was reducing the total cost of ownership by 20%. But despite planning fewer small cells, we were able to place them in the best locations, and this meant that the subscriber experience was improved, and in fact access to 64 QAM, which was giving the fastest data speeds, was improved by 21%. let's look at something else now then. This is 3D geolocation, which is totally unique to Nokia. What we're doing then is building up a very detailed picture of what's going on within the network. We take a detailed 3D map, we divide that into squares, and we use big data and predictive analytics to understand the signal strength in any given location. And this is helping us to find the best locations, as an example, for small cells. But having found the best locations for small cells, we also need to find a way to deploy them efficiently into the network. What we're trying to do then is to group activities together so that we don't just deploy one small cell, but we deploy a whole bunch of small cells at the same time. And we're using things like pre-staging. And in fact, this is a good example of pre-staging. So this particular cabinet then can be designed so it blends in with the background. It can be color matched, as you can see, so it matches to brickwork or a surrounding pole. And it means that you can do a lot of the installation activities before it goes out to site. So you can actually see, here's the FlexiZone LTE small cell. Here's our Harmony Lights microwave. You can install this within the cabinet, make sure all of the cables are connected together properly, and then you can go straight to the site, and this can be deployed in a matter of minutes. We're getting a lot of traction now with our small cells, and based on our observations, we're able to deploy these more quickly than our competition.
And Nokia, they're just one of the big players that's aggressively moving into this small cell space. We were talking while that video played. I think you got to spend some time with a number of other people that are all making moves relative to this, if you can.
Sure, have to. Yeah. So Cavium, which is a chip manufacturer, they announced that they were licensing ARM technology for a small cell solution. What that basically says is they're moving more processing power down to the small cell. And that ties back into that centralized processing versus decentralized processing point I made earlier,
right, to
reduce latency. Okay, so if you're moving everything to the cloud, well, you introduce latency. So by moving higher processing speeds to the small cell, you don't have to bring things back to the cloud. Met with Freescale, they also have chip technology that's putting more processing power at the cell tower or the base station. Ericsson unveiled their rail system, which is a 1-bolt installation product. So when we talk about the streetscape, how do you install a radio head on a tower? And you got to make it simple, because you've got installers who need to be able to very quickly install that gear. So Ericsson announced their rail system, which is a 1-bolt solution. Currently it's only for one baseband or one band, spectrum band, and one carrier, but they say over time they'll be introducing a similar installation mount for multiple bands and multiple carriers, and that's very similar to what Alcatel-Lucent announced last year, where they've got a kind of a single-click mount system. So now you have Ericsson and Alcatel-Lucent both with a easier to install a solution for street lamps. Oracle, I met with their new head of NFV, and he took a contrarian point of view, which a bit surprised me a little bit. He was talking about how their view of NFV and virtualization is to push more processing power to the edge, where you have a 4-blade or 4-server solution effectively at the tower or at the base station, so that with one of those servers being used for caching. So if people are trying to download videos, the videos are actually cached locally. Again, you're not having to transport that all the way back to the cloud. So those are some of the big trends I saw that all tie into your comment about densification of networks. It's more complicated than just adding equipment at the street level. Yeah, a lot of it, and the Nokia gentleman mentioned that in the clip that we played, that what's driving this is just the exponential increase in the demand for data traffic. I think the number that he cited was a 1,000-fold increase in consumer level data demand by 2020. And that's not just a number that Nokia came up. We've heard that from a lot of our partners in the analyst community, as well as from some of the other big vendors and big carriers. So they're all just kind of racing to deploy different solutions, both software driven and infrastructure driven, to accommodate that capacity. One of the more interesting ones that I saw at Mobile World Congress was from Alcatel-Lucent, who you managed. What they're doing is aggregating licensed and unlicensed spectrum around a small cell or another radio node, and then they've got a sort of dynamic switching that moves a user from Wi-Fi or cellular, and then also uses excess cellular to boost weak Wi-Fi, and vice versa. And we got to meet with Alcatel-Lucent. If we could take a look at a demo of that, please.
I'm Jason Miller from Alcatel-Lucent, and what I'll be talking about is one of our announcements that we made this week. It's called Wi-Fi or Wireless Unified Networks. And what Wireless Unified Networks really is the blending of the Wi-Fi networks with the cellular from a data plane perspective. If we look at traditional Wi-Fi today, you've got your downlink and uplink over Wi-Fi. The problem is inherent in the Wi-Fi technology is really on the uplink. So uplink interference as I add users really degrades the performance and quality of Wi-Fi to the point where my coverage shrinks and my capacity on the downlink significantly is degraded. So what we're doing is with Wi-Fi Boost, we're introducing a concept where we take the uplink traffic off of the Wi-Fi and we put it over cellular. Could be 3G, could be 4G. And what this allows us to do is to significantly improve the performance of the existing Wi-Fi network. That's the beauty of the solution is you don't have to make any changes to the Wi-Fi network, but we're significantly improving the performance. So for a congested access point, we're seeing performance improvements of up to 70% on the downlink and an increase in up to 2x from a range perspective. So really significant improvements that can be gained on the existing Wi-Fi network by introducing this technology. And then as we move further down the technology curve, we can actually aggregate that downlink. So we've got an uplink path already to that user. We can actually put a downlink path on the LTE side. And now we've got LTE and Wi-Fi down streaming. And so whatever capacity you add on the LTE from a channel perspective, you can add that capacity to that user. So some of the things we're doing with our partner Qualcomm, you can see speeds on the aggregation side of up to 600 megabits. So significant improvement. So if we look at what Wi-Fi Boost really means from a technology perspective, or just a quick demonstration of what that means. What I have here on my screen is I have a Wi-Fi only, and I have Wi-Fi where my uplink traffic has been moved over to cellular. And so right now, it's perfect. The screens are the same. You can see there's no degradation. There's really no one else but me on this Wi-Fi access point. So what I'm going to do is I'm going to start interference. It's a script that runs and it generates traffic, simulating additional users on the Wi-Fi access point. And what you'll see is that here, where I have the uplink traffic moved to wireless, to LTE, small cell, I'm still pretty seamless. No degradation whatsoever. Over here, I'm already starting to get choppy. You can really see it when you watch the people in the background walk. It's already starting to be affected from a quality, and that's just on the uplink. So that's just a visual representation of what you can do, or what you would experience when you move the uplink from Wi-Fi uplink to cellular uplink. And as I said, from a pure user perspective, when I move the uplink traffic, I see an immediate gain of 25 to 30% on that particular user just with the boost.
So that's Alcatel-Lucent's solution to increasing the capacity for data transfer around these small, dense urban networks. Another product that I got to saw came at your suggestion. You told me I should go meet with the guys from Kumu Networks, and that's a really exciting company.
Yeah, last year, literally in the middle of the show, I get an email saying, hey, you got to meet with this company called Kumu Networks, and I met with them on Thursday morning before leaving Barcelona, and I didn't have high expectations going into that meeting. What I found was a very compelling technology based around noise cancellation, and it was founded by a group of Stanford students and part of a technology transfer out of the university into commercialization, and they were just getting started last year. And so again, I want to make sure we got a year update from what they did. So what were they talking about this year?
Well, I'll tell you, they announced 2 big carrier deals with SK Telecom in Korea and then Telefonica's European subsidiaries. So that's a big deal for them. And I think they've got a lot of other carrier deals in the works. So we're keeping an eye on that. But you mentioned the interference cancellation. So basically when you have these transmissions, a little excess electricity can leak in there and make noise on the signal, and so they can get rid of all that. And aside from increasing your call quality, it does something that's going to be very important as we develop these 5G standards, and that's give you spectral efficiency. So now you can almost double the use of the same little sliver of spectrum. And I think, you know, the AWS auction was a very good reminder of just how valuable spectrum is. So let's hear from Kumu Networks and take a look at their self-interference cancellation.
So my name is Stephen Hong. I'm the Director of Product at Kumu Networks. And Kumu Networks is a company that's developing self-interference cancellation technology for LTE applications as well as for future 5G networks. The self-interference cancellation technology that we've developed allows a radio to actually completely cancel out its own transmission such that it can receive simultaneously. And this allows a radio to transmit and receive in the same band at the same time, doubling spectral efficiency. And that's a big deal because if you look at just the most recent spectrum auctions in the US, 2 weeks ago, you saw that spectrum, small slivers of it, sold for $45 billion, right? And this is a limited asset in which, good spectrum is like beachfront property. And so, to take advantage of that spectrum in the most efficient way possible is a huge priority for all the operators and the entire wireless ecosystem.
So that was a look at just a little bit of the content we produced over in Barcelona. So we got 11 months. You think we need to start planning a return trip?
Well, we don't have time, to rest. We came back from CES and we rolled right into Mobile World Congress. We've got the competitive carrier show coming up, and then we've got the wireless infrastructure show coming up. Then we'll do the TM Forum show. So we've got a full schedule getting ready for next year. But there were some great videos, and I know Dan Meyer's doing his NFV show tomorrow. I think one of his guests is going to be the NFV guy from Oracle. One of our other videos we produced was we had an analyst angle program with Peter Jarek talking to the CTO of Elephant Talk and Affirm Networks.
Yeah,
so I invite people to go check those out. And you wrote a good article on how to monetize NFV. So I invite people to go to our YouTube channel and check out Sean's article. But overall, it was a great show. I suspect that next year's Mobile World Congress is going to be bigger. It's going to be better. GSMA is starting to do these regional events. We haven't attended those, but it might be something we check out.
Hey, lots of exciting stuff at Mobile World Congress, and like Jeff said, I'd really encourage you to check out rcrwireless.com as well as the RCR Wireless News YouTube channel for a lot of great multimedia stuff. And I want to thank you for joining me on HetNet Happenings, Jeff, and I want to thank the folks at home for tuning in.
Thank you.